Welcome back. I'm gonna continue on with some exercises on basic differentiation because I don't think we've done enough in the last lesson, just to give you an idea. So let's do this differentiation here. Y is equal to ex plus x squared. So if I were to differentiate this, so dy dx. Now what we notice is that the differentiation of ex is just ex, and then we add the differentiation of x squared is 2x. So differentiation here is ex plus 2x. So in previously you would have learned the 4 basic rules of differentiation. You're going to need to use those 4 basic rules in addition to the new rule in differentiating ex. So differentiating the exponential function e, x is just the same as all others except we use the additional rule for ex on top of the 4 rules. Here's what I mean by that. So we have the 4 rules. One of them is like the chain rule here, right? So function of a function rule. So what we do is we differentiate the outside and then we differentiate the inside. We can do the same thing for this one here. So let's say take the differentiation from the outside. So if we let u is equal to, let's say u is equal to ex plus 5, then here y is equal to just u7. Right? If we differentiate that, that becomes 7. Remember dy dx using the function of function. This is the outside, so that becomes 7 ex plus 5. I decrease the power by 1, 6. Now I've got to differentiate the inside. Right? So now that I've differentiated the outside, I need to differentiate what's inside. So this is ex plus 5. When I differentiate ex plus 5, the 5 goes away and I've just got ex. So I multiply this by the differentiation of the inside, which is just ex. I put them both together, so this is 7 ex plus 5 to the power of 6. And that's your final answer. So what I'm showing you here is that you need to combine the chain rule, in this particular case used as a function of a function rule. You need to apply that with ex. So although you've learned this rule before, now you've learned the rule for ex, you need to use them together in conjunction. So I want to stress that the 4 rules that you learned, the quotient rule, the chain rule here, and the product rule, which I'm about to do now, you're going to need to use them in conjunction with each other. They don't replace each other, right? So let's do the product rule here. So once again, we have 2 parts here. You've got this part, x squared, and you've got this part, ex, right? So with the x squared, let's call the x squared u, and let's call the ex v. So if that's the case, then u is equal to x squared, u dash, or the derivative of u, is equal to 2x, v is equal to ex, and the derivative of ex, like we learned at the beginning, is the same. So ex is, derivative of ex is ex. Okay, so if we put this together, remember using the product rule, if we have uv, then the differentiation there becomes v u dash plus u v dash. So in our situation, if I differentiate this y dy dx, it will be v u dash plus u and v dash. Now it's important for you to put just the brackets in, and then you can fill in the brackets with your answers. So if I fill in my brackets with my my component parts here, this is my ex, this is my v, so, and then this is u dash, this is u dash 2x, this is u x squared, and this is v dash is ex as well. remember v dash is ex. This is not the same as, I mean, these two are the same, they're both ex, but this is the derivative of this, right? So the answer should be here for you. You just multiply them and put them together. So this becomes 2x ex plus x squared times ex. Now you can factorize that. You can see that x is the same as well as ex, so you can take that out. And this is 2 plus x. So this is to demonstrate to you that you need to apply the exponential function rule for differentiation with the product rule. And I'm going to do another one, the last one being you need to use the quotient rule as well. Okay, so with the quotient rule, you've got your u, this will be your u, this will be your v. Okay, so u is equal to ex, derivative of ex is of course ex. V is equal to 7x minus 3. The derivative of 7x minus 3 is just 7. Remember, the constant disappears because it becomes 0 when you derive it. Alright, so once again, if we put this in our formula, remember that if I derive uv, I should get v u dash minus u v dash over v squared. Right, so this is equal to, sorry, that's a little funny too. This is equal to v u dash minus u and v dash all over v squared. So let's put our numbers in, or our differentiation coefficients back in. So if we look at this, v is 7x minus 3, so 7x minus 3. U dash is ex, right? U also ex, and v dash is 7. So our v is once again 7x minus 3, and put them all together. And so if I look at this, I'll see that there's a common ex. I can take that out. So then this is 7x minus 3 minus 7 all over 7x minus 3 squared. I'm just going to simplify it one more time. So if you look at the square brackets here, let's simplify that. So that is ex 7x minus 3 minus 7, so that's minus 10. So this becomes 7x minus 10 all over 7x minus 3 squared. And that's your answer. So that's a differentiation using the product rule, as well as the quotient rule, as well as the chain rule that we used before. So this is in conjunction with the EX rule. So this is the quotient one. We did one on the product rule, and we did one on the chain rule. So this is just a bit of variety to help you understand how to differentiate functions that may be a bit more complicated. I hope you've learned something in this lesson. I'll see you next time. Thank you.